Okay, shall we start? Okay, hello everyone. Good morning, good afternoon, good evening. So this is TCP Maintenance and Minor Extension Working Group. I'm Yoshi Nishida, one of the co-chair of this working group. Other co-chairs Michael Sharp and Michael Jackson are also in this session. So please go to the next slide. Okay, this is user not well. I think people are already familiar with this one, but just in case, oh, you are moving on very fast. Okay. By participating IETF, basically that means you agree to follow IETF process and the policies. If you have any concerns about it, please check the URL in the slide and then read it carefully. And then also this is, as a reminder, this session has been recorded, so will be published eventually. Please go to the next slide. Okay, this is logistics. We really appreciate Richard for being a note taker. Thank you so much. And then Michael, take care of Java. And then this is simple reminder. When you submit your internet draft to this working group, please include Tcpm in your draft names so that we can track the status of your draft. Okay, please go to the next slide. And this is the agenda for today's meeting. First, the chairs will talk about working group status. After this, we have two presentations for working group item. One is Young TCP from Michael. And then after this, Bob will talk about two ECN draft. One is accurate ECN, the other one is generalized ECN. After this, we have 7 presentations for non-working group items. First one, BD talk about cubic RFC. And as you might know, we have initiated working group adoption call on this one. And then we will make our decision and then make announcement very soon. But at this moment, this draft is still listed as an individual document. So that's why I placed this presentation here. And after BD's presentation, Juhamati will talk about TCP/AO test vectors. After that, Carles will talk about TCP accurate request. And after that, Jiao will talk about MPTCP subtype capability exchange during handshake. After this, Marcus and Jiao will talk about MPTCP lobby. After that, Yoshi will talk about aggregated option for Syn option space extension. And if time permits, Alexander will talk about RTO dependent flow level generation. And this presentation does not have a specific internet draft yet, but this topic could be interesting topic for this community. That's why we press it in the agenda. Any question on agenda? Okay, moving on to the next slide. Okay, so now I would like to talk about working group status. Since last IETF, we have published 2 RFC drafts. One is RFC 8961. This is RTO consider draft. And the second one is RFC 8985. This is RAC draft. And we appreciate everyone for this effort. Thanks so much. And also, we have currently have 2140 base draft. And this draft is currently under ISC evaluation. And moving on to the next slide, please. Okay. And currently, we have 7 working group documents. First one is 793 base draft. And since we have initiated working group last call on this draft, we got lots of useful feedback. And then right now, the authors are working on revising draft to address this comment. And then eventually will be published. And if this draft looks good, I think we can conclude working group last call and then moving on to the next stage. And that's the plan. And then I think we are getting close. And for accurate ECN and the generalized ECN, the new draft has been published, and then we will have a discussion in this meeting. iStart++, the new version of the draft has been published, but we don't have discussion for this draft in this meeting, but we will have a next chance. And the next one is Young TCP draft. And since last IETF, this draft has been updated, so we will have a discussion for this draft in this meeting. And next one's RFC 6937 BIS draft. This draft recently has been accepted as a working group draft, so the discussion has just started. And the last one is EDO draft. And currently, this draft has been expired. But as far as we check the authors has intention to continue this work. So we are just waiting for the new version. That's the current status. Any question to the working group status? Okay, sounds good. Okay, let's move on to the presentation. First presentation, Michael.
Okay, thanks a lot for giving me the opportunity to talk about the Yang module. I hope that you can hear me. This is joint work with Vishal and Mahesh, and some of the content also has contributions from two of my students who have done some work on this Yang module, and I'd like to report on that in this talk. So, next slide, please. So the first slides are just a brief recap of what this draft is about. I'll go through them rather quickly. So this is a relatively new working group item that defines a very basic Yang module for TCP configuration. We have discussed quite a bit about the scope of this document, and we decided that it shall have a very narrow scope. That means it currently includes 4 different parts of the model. 2 of them are very similar to the old TCP MIP. That's basically statistics and a basic TCP connection list. The third item are some configuration parameters that are specifically needed by other IETF activities. That's mostly TCP/AO right now. And then we have a 4th item that basically synchronizes this model with another TCP-related model that's a working group item in the netconf working group. The draft is probably already stable, or it has been stable recently, but the big issue was a lack of running code, and that's what I want to present in the following slides more in detail. If you go to the next slide, I've mentioned that one of the things to be aware of is that there are 2 TCP-related Yang modules in the IETF. It's the one that I present here, and the other one that's done in netconf. Given that there are 2 models, I try to better explain the difference, at least from my point of view, between these 2 models, because they both evolve. The basic difference is very simple. The draft in netconf basically models parameters of TCP as they're relevant for an application, and the specific application in the draft is actually the netconf client or netconf server, but the model probably is applicable to other TCP-based applications as well. So that's the item that exists in netconf. The model that I present here relates to parameters that are inside the TCP stack. That is something that you would typically configure, for example, by sys control statements or some other specific configuration options that the TCP stack offers. There is some overlap between those 2 models, and that's why we also import at the moment some parameters in the Tcpm model from the other one. But from a high-level perspective, I'd like to emphasize that there's a different scope, and I hope that this clarifies why we have two different models in the IETF for different purposes. If you now go more in detail to the specific model that we discuss here in TCPM, the full model is shown on the next slide. If you go to the next slide, you will see the typical tree diagram that's used to show the content of a Yang module. So this is a complete list of the parameters that exist in the model. You can see it fits on 2 pages. It's not a very complex Yang module. It basically consists, as I have already mentioned, of a connection list that's on the left-hand side. The counters that are similar to the TCP map on the right-hand side, and some imports from the other model that I've just mentioned on the bottom part of the left side. So that's the model, and as mentioned before, it's a relatively simple model because we decided to keep it as simple as possible and not to try to boil the ocean. Next slide. The next slide talks about what we've done since the last meeting. So we've not updated the document a lot, but we started to have a look at how we could get an implementation of that model. And for getting there, I've started a small research project with 2 of my students. And I basically told the students to try to come up with an implementation of that model. And the students have at least started to do that. And I'm reporting here on the following slide some of the lessons learned from that implementation. That implementation is still work in progress. So this is an early report. Nonetheless, there are some findings that are probably useful to be reported, and that probably require some updates in the document. And that is then shown on the next slides. We will try to publish the code for this prototype when it's available, but we are not there yet. So now, regarding lessons learned from these prototyping efforts, there's 3 lessons learned. The first one is the connection list. The connection list itself is relatively straightforward, but it's modeled in the Yang module as a read-write model. And that's something that could create confusion, because you could assume that you could use this model, for example, to create a new connection. However, that would be difficult in reality because you typically need an application endpoint for the connection as well. So the fact that this connection is read-write originates from constraints in Yang semantics, not because we want to allow creation of connections by the model. And the plan, therefore, in the model is to better document that the read-write status of the connection list is needed because of Yang semantics. If you want to create a new connection, you would typically have to do that via the application, that is, for example, by a Yang module in the application layer. So that is a relatively straightforward change that we plan to do in the next release of the document. It's basically a better documentation and explanation why the connection list has to be read-write. So that's the first finding. If there are no comments, I'll go to the second finding. The second finding or comment from the students is that it's very hard to understand why we actually import the client and the server groupings from the netconf Yang module. This was originally added to this model to align the 2 documents, but it's relatively difficult to understand why that's actually needed if this model actually models something that deals with the stack configuration. So there's, at least in the opinion of my students, there's no clear use case for that. And one easy improvement would be quite a simplification of the model, just to remove those two imports. If an application needs client or server TCP configuration, it can directly import the groupings from the netconf model and then have the corresponding parameter. So there's no clear use case way to do that inside this model. So the basic proposal here for the next release of this draft is just to remove those two groupings. And if there are no comments on that, I will move on to the last finding. We have in the stats section of the model RPC to reset the statistics. Resetting counters is something that's typically available in routers. So most router operating systems have such an configuration option. The same applies to some other operating systems. For example, FreeBSD probably can do that. However, we try to prototype the model on Linux, and on Linux it's pretty hard to reset the counters because there's no easy kernel support for that. So that's why we could discuss whether to make that reset RPC optional. This would imply that it's a feature in the Yang module. And I see that Richard joins the queue. So Richard, do you want to comment on that?
Yeah, I was just to comment. Getting the net statistics is something that I believe is very useful. And if the base OS doesn't support it, having another mean by, for example, the Yang model, simulating a reset of these statistics would, in my opinion, be very helpful. So I'm don't like this to be optional, quite frankly. Thanks.
Yeah, just to be clear, even if it's optional, it would still be there in the Yang module. We are not suggesting to removing it because it's clear that it's useful. The authors themselves are not entirely sure whether we should remove it or not. I mean, if a base operating system doesn't support it, it could also deviate from the Yang module. So we take this as input to the next release. And if there are no further comments on that finding, I would move to the last slide. The last slide is about other feedback that I got rather recently in discussions with Juniper and Nokia. They had a recent TCP/IO interop between routers, and since this model is about TCP/IO as well, I chatted with Melchior and Craig, and they reported one of the findings in their interop, namely that in interoperability of TCP/IO, it's required to have very clear descriptions how to set the send ID and the receive ID. That is two parameters we have in the Yang module, because this can cause confusion. At the moment, in our Yang module, the description of those two parameters is relatively short. And based on the feedback that I got, we will probably have to make this more explicit so that it's clear how an operator has to set those two parameters if TCP/IO shall be configured. So that's another input that we got. I also asked or suggested to Melchior and Craig that they will give a separate readout on that interop in one of the next meetings, because that's something that might be of general interest. But as I said, there are some specific lessons learned for the Yang module as well. And that's actually all that I wanted to present today. And of course, I'm open to further suggestions here.
Yeah, I have a question. I have a remark. You said that the read-write status of connections is something which looks suspicious to the students. I agree, you can't create a TCP connection, but there might be some use in closing a connection. So at least in HTTP, we have this in the MIP that you can close the connection.
Yeah, that's actually, I think I'm not sure. I think in a TCP MIP there was something in that space. Yeah, we could look into that.
That's possible. So we had this in the SCTP emit because I think Ericsson wanted it. And at least FreeBSD can do it. So from the command line, you can kill a TCP connection.
Yeah, we can look into that. Yeah, that's a useful comment. Thanks.
Okay, Lars?
Hi. So I have a question. As you guys remember, I was pretty negative about this document when we adopted it. And the reason that was brought up at adoption time is why we need to adopt this is that netconf wants it. It turns out now that netconf is still doing their own Yang model, and it's not even referencing this one. And if you look at the data tracker, no other document at the moment references this one. So I just want to ask again, why are we doing this? Thank you.
So the one document where a reference actually should be in place is the one in IDR. So you will notice that Mahesh is a co-author of both. So we are working on getting the reference from the IDR model to that one for the TCP/IO part. So that's the one where you need the reference. From the netconf one, you don't need the reference because you would not reference from an application model something like a syscontrol. You don't do that in reality. So
right, but that was the argument that was made. Why we need to do this is that netconf wants this, right? And now it turns out that netconf doesn't want it, and we're searching for somebody else.
No, we never made. At least I don't think that I've made this argument. It was always IDR.
No, it was netconf. It was specifically netconf when we discussed it. IDR was not even in the picture. Anyway.
At least my memory is different, but I would have to check the minutes. As I said, at the moment, the need specifically for TCP/IO, that comes from IDR. It's not netconf.
Okay, further discussion, take it offline, please.
And other than that, I mean, of course, I know that we can discuss whether to do that or not, but you can see, for example, things like the last slide, having a clear documentation of how to configure certain parameters might be pretty useful, even to people that don't implement the Yang module. So there might be value in just documenting how to configure certain things, even if the exact semantics of the Yang module are not implemented. But that's, of course, my personal view.
Okay, thank you, Michael. Bob?
Hi there. Next slide. This is generalized ECN, or ECN++, as it's called. And really, just one slide. Richard Scheffenegger has been implementing this in FreeBSD, and he noticed one point that isn't in the draft as he was implementing it on resets. He had some places in his code where it did put ECN capability on a reset and others where it didn't, and he realized that would give clues as to the internal state of the TCP state machine. So suggested we add this to the draft, which we've done, that if you're going to set ECN capability on a type of packet, you set it on all of them to avoid leaking information about the internal state. There's also some notes added on ECN mangling. Next slide. That's largely it. Ready and waiting. So I think we can move straight on to the accurate ECN. So this one is there's been a bit more substantial activity. Well, I'm not saying Richard's activity wasn't substantial, but there's been more people involved in this one. So this is the accurate ECN draft that's headed for proposed standard. Next, the problem was to try and make sure more than just one congestion indication per round trip next, and the solution was to use a 3-bit, 3 of the flags in the TCP header that were already used for other things, but overload them as a 3-bit counter, and also define an optional option if possible. Next. So activity since the last cycle, in the last cycle, Joe suggested one possible other way to do 2 orders for the field for the TCP option, because it all depends which code point is more being used. So currently the draft, or at the last meeting, the draft had 2 option kinds, and Joe was concerned they're not necessarily plentiful. So he suggested using the first bit of the first field, but there was some light pushback on that, and actually very early on in this pre-working group draft, a use of the first bit of the field had already been discussed and rejected, so we've left it as it is. Next. So this one was again related to that TCP option. There's some text in the draft that makes sure that there could be forward compatibility, meaning that other option lengths might be defined in the future. So it says that when a TCP peer receives this option, it should not reject it. No, actually must not reject it if it doesn't have one of the valid lengths, so that other lengths can be added in future, but they're only understood by machines with the logic to understand them. And there was some text about how middle boxes that are claiming to be transparent should not or must not reject such unknown lengths if they haven't been updated for a new standard. Michael pointed out that this created a covert channel, so that different lengths could be used, which I've identified now in the security considerations. I said I wasn't personally, I wasn't particularly worried about it, because there are this is a known thing, but it's good that it's prompted an early sector security directorate review, and we could just sacrifice forward compatibility here and just say that these only valid lengths are allowed, but I don't think there's any real need here, which is why I haven't caved and just taken it out, because it's not really a new covert channel. If you go back to RFC 1122, it says TCP must ignore without error any TCP option it does not implement, and obviously you've got a covert channel on any unknown option. You know, you pick a number that isn't used, and that is a covert channel. So this isn't really a new covert channel, and also current intrusion detection systems already close off all these unknown options and unknown lengths by blocking them. So I'm not worried about this. We can have a discussion on the list if you want, but it's important to have pointed it out, but I don't think I'm worried. Next. Yes, thank you, Yoshi. Or whoever's moving the slides, Michael maybe, I don't know. So now we have 3 slides on an area that does need a bit of thought, so sort of heads up. And the Shakespearean question is, to axe or not to axe? That is the question. Now, we have 2 bullets in the text that are the context for this, that were designed to ensure that when congestion starts, it rapidly gets fed back, and that you have a continuous update of the number of CE marks when you've got a lot of them, because we have only a 3-bit counter in the protocol, so that will be wrapping fairly fast. So the first of these bullets says when there's a transition change to CE marking on either a packet or a data packet or not, if it's from not CE to CE, then send it immediately. The second one says after NCE marks, you must immediately send an ACK, but N can be anything between 2 and 6. But it should be 2. because the counters can only count 8. While reviewing this, I realized that that would also mean that you would have to send an ACK of an ACK if there was a series of ACKs all with CE marks on it. And then we thought, well, actually, let's not necessarily remove that possibility because that might be useful. And actually, it's the principle of not ACKing ACKs in TCP doesn't really apply here because it's new information. There's new congestion information on the ACKs, so it's not as if it's just not new information and therefore doesn't need ACKing. It's a bit radical to think of ACKing ACKs, but we thought a bit about this, and we thought the cases where this applies, the only cases where this applies as far as we can think, is where you've got a volley of data as shown in the picture, and the ACKs are obviously coming back from that, and in this case they're shown red, which means they're CE marked, they're congestion experienced, and then there's this possibility of ACKing every n of them. In this case, every second one. It shows that the host on the right is actually getting some feedback of its ACKs once the data stops. Obviously, if the data was still going, that feedback would be on the data because the counter just goes with the data, and then there's potentially a ping pong back to the other end if that sequence of ACKs is also congestion marked. But it's sort of unlikely that large amounts of them, but this is the sort of corner case where everything is CE marked. So that's the question. Now, if we move on to the next slide, Yoshi pointed out if we do ACK-ACKs, there is another wrinkle in that if the data direction changes, as shown here, the data is the thicker arrows, and it changes quickly before an ACK has arrived, then those ACKs will look like duplicate ACKs because the right-hand host doesn't know that it just looks like the round trip time has suddenly got shorter, and so we realized though that maybe this is okay because you can detect it, but it's already a bit of a corner case, and if you've negotiated SAC or timestamps actually, then you can eliminate this by just checking if you think it's a dupack. If it's not got SAC on it, then it's not a dupack. And even if you didn't bother to add that to your code, you'd get a spurious retransmit in a corner case. So it's not particularly worrying to me anyway, but others may think otherwise. So now we come back to, on the next slide, the original question of do we ACK-ACKs or not? And there are two positions. We could either just prevent ACKs of ACKs completely, and the green text there just says only ACK and ACK, or if there's outstanding data to acknowledge, then it won't be a duplicate ACK and it's perfectly valid to do so. The other one is to take the opportunity to feedback CE on these ACKs, but damp any ping pong. And so we thought if we make the numbers here, n should be 3 and must be in the range 3 to 6, it will damp it quite fast. It won't make it any more complicated so that data and ACKs can be treated the same. And actually, there are complexity and simplicity arguments on both sides, in that in the first case A, by not feeding back ACKs of ACKs, you can get a build-up of congestion marks on one end, and then when data is sent, you get this sudden multiple wrap of the counter at the other end, and you'd have to deal with that in the code, or you'd have to ignore it and then deal with the consequences. So of possibly missing a load of congestion.
Okay,
So
Bob, please speed up.
Yep. I've written all this on the list, And I'd appreciate any comments on that on the list, or if they're quick here on the call. And I think that's it. Next slide is just a wrap up one, I think. Oh no, there's you can jump through this. Some editorial work has gone on, thanks to Gori for the review, and then finally the status on the next slide. Again, once we've resolved this acts of acts thing, I think we're again ready for working group last call. And just as I just pointed out, the generalized ECN1 depends on this, and we did say back in April 20 that we would wait for L4S for a bit and otherwise go ahead with this. So I don't know what you plan to do about that, Yoshi.
Okay. Is this end?
Yep.
Okay. Any question? Martin?
Yeah, thanks, Bob. Yeah, I agree this is close. Can you go to slide 5? Do you think by your definition, is a TCP proxy that splits the connection like a PEP or whatever? Is that transparent?
The definition of transparent is that the TCP headers, that the wire protocol doesn't look any different from one side to the other, so it's probably not. You know, certainly it would be very difficult to make everything look the same and have the same timing.
Right.
What was behind the question?
Fair enough. Well, so I wanted to make sure that was. I mean, I think you probably see the why this wouldn't work for a terminating proxy, and we were just talking in Java. Like, just my interpretation of the word transparent is the endpoint is not aware that it's not talking to the end server, which would include PEPs. So I guess this is a wordsmithing thing. I think we just maybe need to pick a different word. Thanks.
Right. Yep.
Yeah, very quick.
Yeah, I just want to add one small comment on the egg of egg thing. I think this is really a decision what we want to support, because if we don't egg X, then there is a risk, a very minor risk, but there is a risk that the counter might wrap and we might lose some information. If we have this X of X, we are more accurate. And currently we don't need this information. Currently we can't do anything with this information, but in future this information could be used for egg congestion control. So, you know, I think that's really the question that we have to answer here. If we want to support already something that is maybe needed in future for egg congestion control, or if we want to leave this kind of as a separate topic for future, which might then need more effort.
Can I just come back on that, Mia, Yoshi? If you can go to slide 6 or 7, maybe 7, I think.
Okay.
It's not just for egg congestion control. In this case, where you're exchanging volleys, one end sends and then the other, you've got congestion information. No, that one. Yeah, that's right. You've got congestion information. If you're on the right hand side, before you start sending, you're potentially getting congestion information about the direction you're about to send in from the ACK stream of the that you've just been sending on that direction. So that could be used now to maintain your congestion window before you actually start sending a volley.
Okay.
Yeah, I mean, yeah, so I think the more important point I wanted to make is, like, in one case we might actually lose some information, in the other case we're more accurate and have more X.
Yeah.
That's the trade. Yeah.
Okay.
Yeah, thank you, Mia.
And please provide the feedback on the mailing list. Thank you, Bob. Okay. Moving on to the next one, BD.
Audio check. Can you hear me?
The volume is a little low.
Okay, I think it's the headphone. I think I'm going to take it off. Is it still low, or should I try this?
No change.
Okay, I think that's the headphone. 1 second, please.
Hello, is this better?
Yes.
Much better.
Okay, sorry. There might be echo without the headphone, but sorry if there is low volume on the headphone. Hello, everyone. I will talk about the updates that we have made to the Cubic Informational RFC 8312 to adapt to the recent advancements in transport protocols. Next slide, please. Some of the variables and constants you guys already know, and if for reference, I have put them down on the bottom of the slide. One important variable that we are adding to the revised draft is CVIN start, which is basically the congestion window at the start of congestion avoidance. Here's why we have done that. Some modern networking stacks implement RFC 7661 for a better estimate of network capacity for rate-limited applications. Now, this RFC uses either the pipeback value or the loss flight size value to determine the slow start threshold and congestion window after a congestion event. This means that CVIN start could be smaller than the product of Wmax and beta cubic. The second reason to use congestion window start is that if fast convergence is applied to make room for new flows, Wmax is further reduced, but we don't want to change the CVIN start when this happens. With that in mind, let's take a look at K, which is basically the time it takes to increase the congestion window size at the beginning of the congestion avoidance to Wmax. In the RFC 8312, after the congestion event, CVIN is set to the product of Wmax and beta cubic, and the same product is used at the beginning of the congestion avoidance. This resulted in the simplification of K's equation, which you see on the left. Now, as I discussed earlier, CVIN start could be completely different from the product of Wmax and beta cubic, so the simplification on the left becomes invalid. So in the revised draft, at the start of the congestion avoidance, we are using the unsimplified version of the equation, which you see on the right, which is basically Wmax minus CVIN start by C. The last bullet point in this slide, in accordance with most modern networking stack, we have added text to specify that the implementations can use fast recovery mechanisms after a congestion event and then gradually adjust the congestion window to its reduced SS threshold value. Next slide, please. Here I'm showing the window increase function used by Cubic on receiving an ACK during congestion avoidance. RFC 8312 says Cubic computes the target increase rate during the next RTT using the W cubic T plus RTT equation. This equation could have possibly 3 outcomes as shown on the slide. For the first case, we have added a lower bound when the target could become smaller than the current congestion window. Although this might not happen, it is an added safety guard. The second case is more common during the app-limited periods where time t keeps increasing even if the sender is app-limited. So similar to what Linux already does, we have added an upper bound to make sure that the growth in congestion avoidance is slower than doubling the congestion window every RTT. And the third case is the generic case where we will use W cubic T plus RTT as it is. Next slide, please. The term TCP friendly was used in 8312 as Neurino was the only TCP congestion controller widely deployed at the time. Now that we have other congestion controllers, including Cubic, we have updated the draft to use the more accurate AIMD friendly term to refer to the AIMD-like growth. Next 2 points talk about the changes to the AIMD friendly window W estimate for Cubic. Time-based approach, which was defined in the 8312 RFC, it doesn't work well with the app-limited senders, as the W estimate will grow even if the app is not sending a lot of data. So in the revised draft, we switched to the more precise ACK clocking method based on the segments acknowledged. To do so, we first initialize WEstimate to the congestion window at the start of the congestion avoidance, and then we increment it based on the segments that are getting acknowledged. Next slide, please. There is another update in the draft for the AIMD region. If we use the AIMD region, AIMD approach based on the segments acknowledged, we have to make sure that once WEstimate reaches Wmax, we set alpha AIMD to 1, which is similar to the new Reno behavior. I created two graphs with some sample values to depict what I'm trying to convey. The scenario begins with is that we begin with slow start and see a loss event at congestion window equals 10. Then we set the Wmax to 10 and reduce the cubic congestion window to 7. While if new Reno was used, its congestion window will get reduced to 5. After that, we follow the WEstimate function for cubic and the AIMD function for new Reno. If you look at the left, once the congestion window has reached Wmax, if we continue to use the same alpha AIMD for WEstimate, as we saw on the previous slide, cubic will have a slower growth as compared to new Reno. This is fixed on the right by setting alpha AIMD to 1 once WEstimate reaches Wmax, and thus we have the same growth as new Reno after that point. Next slide, please. This is the last slide. There are a lot of other updates that will make the life of an implementer much easier. Firstly, we have added some edge cases by adding a lower bound for congestion window. We have also added definition of variables and constants along with their units, which would come in handy. Christian, who implemented cubic for Pico Quick, had raised an issue to document the cubic behavior on spurious losses, and we have added a whole section for that. We have updated the terminologies that make most sense in today's networking world. We have also documented the broader deployment of cubic over the past decade. As some of the developers refer to the cubic research paper for the pseudocode, we have highlighted the differences between the research paper and the cubic internet draft for better understanding. And the thing that will be most useful is the pretty LaTeX math for the various equations and formulas, which will make your life easier while they're looking at those equations. We hope that this new revised draft will make it easier for an implementer to adopt cubic, whether it is for TCP, Quick, or any other transport protocol. We intend to move this draft to the standards track, obsoleting the informational 8312 RFC. Thank you for listening.
Yeah.
I'd
Thank you,
be
Bidi.
happy to take any questions.
Yeah, thanks, Bidi. One question is, you guys still are using GitHub to tracking issues, right?
I lost the audio. I don't know why.
Okay, sorry.
I muted
So-
you because there was echo.
Okay, while Vidi gets her audio work, yes, we're using GitHub to track the issues.
Okay. Then, yes, if you have any comments, please send a mailing list or create the issue on the GitHub. Yep. Thanks so much. Thank you, Bidi.
Thank you.
There's an adoption call ongoing. Do you guys recall when it ends? Is it today?
I think it's about today, yes, or yesterday, or something like that.
The determination of what happened.
So we haven't talked
So
about
Does the next version going to be draft IETF or not?
We will let you know.
Hmm.
So we send the result to the main ones.
Yeah. Okay. Juhamati. Thank you, Bidi.
All right. Can you hear me?
Yes.
Great. So my name is Juha Kuusisari. I've been working with Joe Thatch with Tcpm test vectors. Thanks for giving us a slot here. Next slide, please. So here is a brief summary about the draft. It was already presented in the summer IETF. So the idea is to document test vectors for 2 algorithms that are specified in the RFC 5925 and 5926, and also include the version where options are not included to the message authentication code. So it should have all needed for the implementer to really implement the support for the authentication option. It includes IPv4 and IPv6, and it has the keys and the TCP/IP header and the message authentication codes MAC for the verification. And the known implementation issues are discussed. Feedback is welcome if there are implementers that have more than included in this draft. So please let us know. Next slide, please. So there are a couple of new drafts since the last IETF where we presented this. So test vectors 01 was published shortly. So during testing, we actually found that there is an issue in our key derivation function, and we updated the draft accordingly. And after that, we got interoperability with 2 vendors, actually. So we managed to get a routing vendor in our lab, and there we were happy to see that it fully works with regarding the test vector. So both algorithms and also both option versions work fine. And we were also collaborating with the fuzzing vendor during last fall. The fuzzing vendor also gave us a test version of their new implementation, and he was working with us. So we have now 2 vendors working. The fuzzing vendor only implemented the SHA-1, so we are waiting for the IS 128. But anyway, looks pretty good. And they had the draft as input, so that probably helped them because we didn't get any feedback until they actually just gave us the new software and it was working straight away. So that was the story of that. And then the IPv6 was still missing, so we added it in the 02 draft. As such, the IPv6 is pretty minimal regarding the implementation, so only a few lines of code were changed in our implementation, so it should be pretty straightforward. And the pseudo header is the only handling that is different, really. So in that sense, we don't expect any issues, but still we don't have interop with IPv6. We don't have in the lab any equipment that supports that. So feedback for the IPv6 part is welcome. And please send us if you see any issues there. We are planning to have it tested one way or another. And next slide, please. So this draft is intended as informational. So as such, if we don't find anything new, we consider it ready for working group adoption. And we would like to request the working group adoption if you choose to consider it at this point. The plan for the IPv6 is probably to get the feedback and maybe have a hackathon if we get hackathon attendees, but let's see. I have already initiated this discussion on the hackathon mailing list. But of course, this is for the future IETFs then. So thanks. This is all I had.
Okay, Michael.
Yeah, this is Michael speaking as individual contributor. I just want to give a heads up. We are referencing this draft from the Yang module, and that would be one of the reasons to actually adopt the document in my personal point of view.
Thanks.
Okay. So I think this draft has, very clear, straightforward vision, so people can easily understand its, purpose and its usefulness. And then we have discussion. The chairs have discussed about this one, and I think the draft is, ready for adoption call, basically. And so what I would like to check is if you have any concerns on running adoption call on this one, please speak up right now. Otherwise, we will move on to the adoption call. Any objection or any question? Okay, then I think I will move on the adoption call. While I'm preparing, if you have any clarification, please speak up. Start the call. So if you agree to adopt this item as a working group item, please click raise hand. And if you disagree, please click do not raise hand. If you don't have a specific opinion, you don't have to do anything. Please start. Okay, I will wait for another 10 seconds just in case. Okay, stop. 6 raise the hand, and then 0 disagree. Okay, thanks for the statistics. And then we will make a decision and then make some announcement on the mailing list later. Thanks so much. Thank you to Hamati. Oh,
Thanks.
Bob, you.
And thanks to Joe for editing the draft. It's really appreciated. Thanks. Bye.
Thank you.
I just was going to point out that normally with an adoption call, you also ask how many people have read the draft.
Yeah. Maybe I will check later. Sorry. Okay, next chorus.
Okay, hello everyone. I hope you can hear me. So I'm going to present the last update of the draft entitled TCP accurate request option. Next, please. So first of all, a reminder of the motivation for this draft. Delay tags is a widely used mechanism which is intended to reduce protocol overhead. And however, it may also contribute to suboptimal performance in different scenarios, such as the ones identified here. as large congestion window scenarios, meaning a congestion window size much greater than the MSS, and small congestion window scenarios, meaning a congestion window size up to the order of 1 MSS. In the first case, saving up to 1 of every 2 acts might be insufficient. For example, there are performance limitations due to asymmetric path capacity, or if we want to reduce the computational cost and network load of too many acts. And in small congestion window scenarios, we may find data centers where the bandwidth delay product may be up to the order of 1 MSS. And in that case, delayed acts will incur a delay much greater than the RTD. And also, there may be transactional data exchanges, or when a congestion window decreases, the ability of eliciting immediate acts may help avoid idle times and allow a faster congestion window growth. Next, please. So about the status of the draft before the creation of the first version of the draft, there was some related prior discussion in the area of sender control of TCP acts, which seemed to converge to defining a new TCP option serving two purposes. One is the ability of requesting a given act rate from a receiver, and another would be the ability of requesting immediate acts. So the previous versions, 00 and 01 of this draft, were presented in the last 2 IETF meetings, and the current one is 02. This is presented today, and it aims to address the comments received in the last meeting. Also, the main option format size has been reduced by 1 byte, and also we have added content in the security consideration section. Next, please. So now let's take a look at the updates in 02. Well, as in the previous version, there are 2 formats, okay? But the novelty would be that those would be distinguished by the value of the length field. So the 2 formats are the one on top, which is to announce support of the option, and the second one, there's one bullet that didn't appear here for whatever reason. The second one is the main one, which conveys the values for the main parameters of the option. So because we are using 6994 style for this experimental TCP option, then we would use the same kind value for both, which would be either 253 or 254. So again, the novelty is that we will distinguish the 2 formats by the length field. So next, please. Then we have also introduced a change in the main format, which originally was of a size of 7 bytes. And the new format, again, there's some bullet which is not present in the middle of the slide, which anyway, the new format is the one below. So it has been reduced to 6 bytes. Here we have reduced the ignore order field from 1 byte to 1 bit, and the R field has been reduced from 8 bits to 7 bits. So overall, we have this decrease by 1 byte. Then also there was an email yesterday by Michael Scharf suggesting a possible new arrangement for the main format, by which we might even decrease by 1 further byte that format. And that would mean that if we go that path, then the values for R and N well, might be lower, let's say, or we might have to represent a lower range of values for those parameters. As a reminder, R is the ACK ratio, after how many full-size data segments the receiver will transmit an ACK, and N is the number of subsequent data segments for which we are requesting immediate ACKs when R is set to 0. So yeah, we may want to discuss that and consider that as well. And it would be good, by the way, to know if the working group thinks that it's necessary to represent values for R and N greater than 63. So there was already one answer by Jonathan on the mailing list mentioning that perhaps it's not necessary, but it will be good to see if anyone thinks otherwise. Next, please. So we've also added content in the security consideration section because this new option would also create some new form of attack by which an attacker impersonating some legitimate sender may communicate about R value to a receiver that would be a too high R value in a small congestion window scenario, or conversely a too low R value in a large congestion window scenario. So one example of the last case could be communicating such a low R value to some battery operated receiver with the aim to lead it to transmit too many acts, which may contribute to decrease the amount of energy available at a much faster rate. So the goal may be in general to damage or degrade communication performance or degrade the performance of a device. So as possible mitigation, well, since TLS doesn't protect TCP headers, then one approach could be perhaps using IPsec. And next, please. So after publication of 02, we requested IANA to allocate a value for the experimental ID. So this is a 2-byte experimental ID, which is 00AC, as you can see on the screen, which somewhat tries to allude to ACK. And well, it was quickly allocated, and you can see on the screen the current state of the registry, where, well, this new value is actually the first one. Next, please. After publication of 02, also there was a review by Yoshi. By the way, thanks a lot to everyone who's giving feedback, Michael, Jonathan, and also Yoshi for the very useful comments and feedback. So the main point in Yoshi's review is that we may want to provide guidance on when or how the sender would use the features in this option. And for example, about setting the ACK frequency in some cases, or many cases perhaps, in those small or large congestion window scenarios, perhaps it's enough to just set the ACK frequency once in a connection lifetime. And perhaps that could be the case, but we may want to double think whether there are maybe other different cases. Also, we may want to provide guidance, for example, when reordering is not supported, also about how to set the N parameter. And specifically here, there was a question about whether we might want to be able to set R to 0. That would mean requesting immediate acts for the entire connection. So perhaps we could enable something like that by reserving some special value for the parameter N to represent infinity. And well, in addition to that, there are a number of editorial clarifications and suggestions. So thanks again for the feedback. And our plan would be to incorporate all these in the next draft update. So next, please. So considering that at least there's some relatively stable basis now for the document, we were wondering whether the document could be ready for working group adoption.
Okay, any questions? Cory?
Yeah, what do you think the baseline is that you're working against? I mean, because I see offload engines reducing the ACK rate commonly across internet paths. So what baseline are you looking at, and how will you interact with offload engines?
Yeah, that's a good point. We need to look into that area. So currently we were not actually assuming any specific baseline we would compare with or against. But yes, I don't know if anyone or if you have any suggestions as to what are the usual numbers or figures that can be found in nowadays, well, in any existing deployment.
Yeah, I was looking for you, but I can happily comment on that later on the list.
Great, thank you.
Okay, so I basically have a concern about ignoring reorder. I think this is the comment from Jana, I guess. And so if we ignore the reorder, fast retransmission may not work. And then, so in case of Quick, this might be okay because Quick is timer-based retransmission scheme. But in case of TCP, with rack is not always supported. So sometimes we need to rely on fast recovery, fast retransmission algorithms. But if we ignore reorder, it might not work, and then we might have to wait for timeout. So I just would like to hear about what's use case ignoring reorder more precisely. That's otherwise it's to some extent it's risky from my point of view.
Yes, so yeah, I agree that we may need to clarify in the document to provide guidance of when it's safe to use this feature, and advise that, well, otherwise there can be the issues that you just mentioned.
Mm-hmm. Okay, any other? Okay, Michael? Michael?
Oh, I had to click OK. Is there any experience with implementations?
I'm not aware of any at the moment. So if anyone has any feedback on this, it would be very helpful.
Okay, Jana?
Hi, thank you for this. This perhaps a comment or a question for the chairs. It seems like, I mean, this is certainly interesting, but the real question here to me is how valuable is this, and how much real world impact this can have. This is following up on Gauri's question, and maybe yours as well, Michael. If we don't have a real implementation, if we don't understand what the implications of this are in the real world, and if we don't understand what real value this has, I don't know how to evaluate whether something like this should be taken up in the working group or not. I think it's a perfectly fine mechanism. Like, it seems reasonable, and all of that is fine. But the real question is, do we gain anything from working on this? And I don't have any evidence to claim yes or no.
Yeah, basically so Jana, basically that's why I'm asking the authors to provide some kind of use case, more tangible use case. Then we can think about, okay, this is very useful use case, and we can use it.
Well, so perhaps that's not like we don't have implementation experience by using this option, but as the motivation, there's a different set of scenarios mentioned in the introduction, and which well, can be categorized in some cases into those large or small congestion window scenarios. So yeah, at this moment, we have not been able to make experiments with implementations and measure the performance when we use something like this. But we have some reference from use cases, let's say, where we might improve performance. So yeah, we may want to cover the implementation part, but at least we have some motivation and some use cases where this could be useful. But anyway, yeah, I also agree that we may want to provide more guidance, as Yoshi said.
Okay, Ingmar, please click.
One asking about use cases. One typical use case for this, I need to admit I haven't read the draft in full, but one use case is 5G systems with that runs on millimeter wave, in which case you might easily have user equipment that are power limited in uplink, which can give, in some cases, quite asymmetric behavior depending how networks are deployed. And then it's good to have some kind of negotiation with that, send that, ask for the accurate that you need, but not more. That could be one use case that where this can be good. And that can also send a signal, for instance, to 3GPP that this is taken seriously, and we try to devise methods to avoid too much acknowledgements or more than necessary. and then you avoid the other ACK aggregation features and ACK discarding and whatever that might otherwise be the option.
Okay. Or if your comment is very small, very short, that's okay. But please do not ask long questions, long comments.
Yeah, I agree with Ingemar, but the problem is knowing that the links are on path and knowing that the endpoints want to do it. And we have a draft that talks a little bit about this in quick. So I think let's talk more is what I'm saying.
Okay, thank you so much. I think we still need some more discussions. Let's continue the discussion on the mailing list. Thank you, Carlos.
Okay, thank you. Thank you.
Okay, moving on to the next presentation. Jiao.
Can you hear me clearly?
Mm-hmm.
Okay. This presentation is about a new function in MPTCP. We call it subtype capability negotiation. First, I should be honest that this is idea. I have no demo to show this function. That's the status. Okay, next page. As you all know, version negotiation has been defined in MPTCP protocol. This page lists some case for version negotiation that we can find that in a definite version, all subtype messages are mandatory and fixed. This is why I present this idea. Okay, go to next page. This page is the requirement for scalability and performance optimization. Left table have list all the subtypes that have been defined in MP protocol version 0 and version 1. From the evolution, you can find some new subtypes that have been defined. So we found that if a new message type, subtype message type is added in the future extension, a higher version should be released to import it, and maybe a new subtype should be allocated. And then the next issue that I think it may be happened in the case that dynamic function deployment be imported in MPCP. That means that if a sender does not know the subtypes supported by the receiver in a MPTCP session, as a result, invalid data package may be sent during data transmission from the sender to the receiver, and it will and for the receiver, for it cannot support it, so it will discard it, which will cause system overhead on receiver side. Next page. So I think for subtype capability exchange, there are, from my understanding, there are 4 scenarios. First, that each peer's initiation support same MPTCP protocol version, including same subtypes sets. And the second is that the peers support same version but with different subtype sets. Second is that the peers support different MPCP version, include same subtype sets. The last one is that peers in the session support different version with different subtype sets. I think the last 2 scenarios more complicated. So this current version, the draft is current is cover only the first 2 scenarios that they are in the same version but include different or maybe same subtype sets. Okay, please go to the next page. I think a typical flow for this function between 2 endpoints is like in the picture. I suggest this exchange happened during session during connection established. the sender will carry its subtype capability in the first message when it want to set up the connection, and the receivers receive the subtype capability will determine and catch it, and then in the response it will carry his own subtype capability, and then the initial will determine and cache the capability from the receiver. So for the two parses, we know the stability of subtype from of each endpoint. Then during data transmission, before they send the subtype message, he know whether the receiver will support it or not, and it can avoid, as my understanding, it can avoid the invalid message sending. Next page. Okay. This page just give one possible solution on the protocol design, and maybe it's not visible currently. There's maybe some problem that on compatibility, and I will consider it later. First, I think maybe in the MP cap option can allocate some bytes to indicate the each capability indicate the capability for each subtype. There are some bytes, and each byte will corresponding to one subtype, and to indicate whether the sender supports the subtype or not. This is maybe it's not pure, but I think we may think it in deep in the future version. Okay, let's get next page. Yeah, I think this currently it is our own idea, and I'm not think whether this requirement or scenario is interesting or useful. If it yes, I can go ahead to complete the chapter in deep and considering more use case for it. Thank you. That's all.
Any question? Yeah, one comment I have is, I might want to see some more tangible use cases. So basically what you are saying is, if the endpoint knows which subtype is supported at the initial stage of the connection, then you might want to avoid sending a waste of the packet. But let's say if I send a specific option in the middle of the connection 3 times, and then it fails 3 times in a row, then disable this feature. This is also possible, right? And then, so it's a pros and cons. And then I still want to see, which one is better. And so if you could provide more useful use case, that would be great. That's my, initial impression. But that's my personal opinion, not that with shared hub, obviously.
Okay, thank you, Yoshi.
Martin?
Thanks for the draft. So is there a problem with V0 and V1 MPTCP hosts not supporting all of the subtypes, or is this solely about creating extension points so where we don't have to create a new version?
I'm not very sure whether I mean that I'm not very sure which the extension about MPTCP. So I still research on. I will discuss with my team about the possibility about the See.
Yeah, Martin, it depends on implementation.
So there, I mean, I'm not familiar with the universe of MPTCP implementation. So this is addressing a current problem. It is not just a thing of extension points.
Well, we need to discuss. Take it offline. Yeah.
Fair enough.
Yep. Okay. Thank you, Jiao. Okay,
Thank you.
next presentation. Marcus, it's your turn.
Can you hear me? Very good. Okay. Yeah. I want to talk about again want to talk about the multi-pass TCP robust session establishment, something we drive since several IETFs. That's a joint initiative between Huawei and Deutsche Telekom. Next slide, please. Just a short recap. Multi-pass TCP Roby tries to overcome an issue we see with the regular multi-pass TCP, which means if in the regular multi-pass TCP the initial flow cannot be established, then there is no connectivity. And with 3 different proposals, the Roby SIM, timer, and IPS, we try to overcome this. With the Roby SIM, we simultaneously establish a communication over multiple paths or all available paths. With the Roby timer, we will try to set up a second communication when the first communication fails after a timer expires. And with the Roby IPS, we use some available information to decide whether to use a first path or a second path to establish the communication. Next slide, please. While all these proposals are well described in the draft, from our standing, we tried to get adoption, or we requested adoption last time, but that failed because there was some feedback during the IETF 109 session where 2 issues came up. So the first one was about that the existing IPR allow implementation in an open source initiative. And the second issue was, is there a way to publish the existing implementations in Huawei open source? So the following slides will deal with this question. So please, next slide. So coming to the issue 1, license clarification. So that is a slide provided by Huawei, and I will try to summarize it shortly and will not explain everything. So Huawei is part of the OIN community, that is the Open Invention Network. And within this Open Invention Network, Huawei will share, or that is part of this OIN community. So everyone who is part of this has to share their patents, which are Linux kernel related, free of charge. So that means from our understanding that this is a first good step, because everyone can profit from this, from being part of this OEN community and have access to this patents free of charge at the end. Next slide, please. Yeah, then open source status. So part of the Roby IPS, so that is one of the solutions we propose, are more or less indirectly open sourced by Huawei, because it's part of their product, and everything which is under the GPL has to be published by them, and that you can find under the link which is mentioned here. But nevertheless, independent from the open source status, we also provided at IETF 108 some prototypes and gave some insights into the results we were able to together with to connect with these prototypes. So there are some initiatives which I've already shown that. First, the different Roby proposals work, and that we have done with prototypes. And secondary, part of this prototype implementations are already open sourced. Next slide, please. Yeah, and now again, our question: are the proposed measures and declaration and disclosures enough to proceed towards working group adoption. Yeah, so that was the final slide, and I would be happy to get some feedback from the audience.
Okay. Any questions? Michael?
Yeah, this is not asking as a chair, but as an individual. You said it's, so if I'm implementing this for Linux, it's okay. That's
so
at
least that is, sorry, go ahead, please.
So what does it mean for non-Linux implementations?
So to be honest, maybe Chiao can jump in here, because this information was provided by Huawei, and at least it says when there's a member in the OEN, then this means all the IPR protected developments can be shared for free. If this is also related to FreeBSD, for example, I don't know, but maybe Chiao, you can give some more information.
Okay, the license information is provided by our ledger person, so I cannot answer the question about the license personally. If any question about the license, you can write in the minutes. I can forward it to my company and to my ledger person, and he will give us a formal material. I think that is a good way to discuss the problem about the license.
Okay, thank you.
Okay, Michael?
This is Michael speaking. Also on the license question, as far as I recall, there are two IPR disclosures, one from Deutsche Telekom and another one from Huawei. Now we have seen a slide that probably discusses the Huawei IPR, and you've mentioned that this slide was provided by Huawei. So what about the other IPR?
Good question.
Is it correct to rephrase the slide that is not discussed on that slide? The Deutsche Telekom IPR declaration.
So if I got you right, you asked for the Deutsche Telekom declaration. So we are currently thinking about, unfortunately that was not part of this presentation, to give this free for non-commercial use. The question to you or to the audience is, would this be enough to get working group adoption?
Well, that's not something I can answer as chair.
It was not just a question to you. I think that is a general question.
But I also think, I mean, if you want to get a reasonable answer to this, you have to probably write that down so that people can read it and think about it on the mailing list. I'm not sure if we can orally discuss this question. I understand what your suggestion, but I do think this needs. As if you think about it, you should write it down so that people can understand what your thinking is and comment on it.
Okay, next. Michael, could you go back to slide? So I particularly noticed the one line. Go back one more. Yeah, that one. Next one. Yeah. Oh, you skipped
the license clarification, I think.
Yeah, that one. No, that one. Yes. And then I'm really care about the third line in the answer. So it says with possible royalty fee. That's raised my concern. So I mean, there is a possibility that we have to pay royalty fee, and then the amount of the fee is really ambiguous. It's a possible royalty fee. And
so if I read this correctly, at the end of this yellow box, there is, so for all the members of the ORN community, it's free of charge.
But if I'm not a member of the OEN community, then what will happen?
That has to be answered by whoever, not Chuck.
Okay, yeah, I think that should be clarified, I think. That's my personal.
I will forward your question to my major person, and he will give you an answer.
Okay. Russ?
Hi. Yeah, speaking as an individual. So there's one example we have in TCP with the RFC that we did that has IPR, if I remember correctly, which was IFO. And the existence of the IPR has basically meant that nobody ever implemented it. And we expanded working group cycles on it for no reason, for no benefit. And so I personally, I mean, this is even more complicated because there's two people declaring IPR that are potentially conflicting things. I don't know what this orange box is trying to tell me, but nobody will implement this with this confusing IPR. So we should not spend any time on it discussing it in the working group. If you want it to be implemented for TCP or multipath TCP, it needs to come under, no obligations that are not understandable. So I don't. This is so complicated. I don't think it's fair to ask us to evaluate this. Like, I would need to give this to our lawyer to figure out whether we could do this.
Last short question here. Do you think it would be just sufficient to give it free for non-commercial use?
What does that mean? Linux is used for both commercial and non-commercial purposes. And if you want to implement it in the Linux kernel or FreeBSD or any other operating system, does the user need to check whether each application is making use of this commercially or non-commercially? This is not working. It can't be tied to the use, right? And specifically also with the GPL, right? If I remember correctly, the license holders, IPR holders, need to give the license for free, otherwise the thing doesn't get merged. And so, I mean, this is such a complicated setup that is created with this document that I don't think we should adopt this. This is nothing to do with the technical quality. I want to make this clear, right? This is purely based on the licensing, because I don't think anybody will want to run the risk of tainting their implementation by touching this. And so it's dead, I think, unfortunately.
Okay, Michael?
Yeah, as an individual and as a FreeBSD committer, so I wouldn't implement it, at least I wouldn't commit this to the FreeBSD tree, because someone might use FreeBSD and not knowing that he's running a business, not knowing that turning the syscontrol on or off gets him into the need of paying something. So either it's free or not. It's a Boolean question for me.
Okay, Corey?
Just echoing from Jabba, there's Tom Jones and John Morton saying also the same as other people are saying. If it's not clear of the IPR, then they won't upstream it.
Okay, it seems to be you need to clear the license issue more precisely. Otherwise, it's very difficult for people to think about implementing this one. So please continue discussion on the mailing list a little bit more. Thank you so much.
Yeah, thank you.
Oh, Martin, you have some comments?
Yeah, just very briefly, before we ask Marcus to bring us a rock, it might be useful, maybe not right now, but either in the Java or on the list, that if people are actually interested in this, but for the licensing, before he goes and fights a legal battle, to let him know that, rather than just have him go do this, then people don't like the work anyway. So, I think some comments, leaving aside the IPR issue, would probably be a considerate thing to do. Thanks.
Okay, so next presentation is me. Okay, so yeah, my name is Yoshi. I would like to talk about aggregated option space for Syn option space extension. Next slide, please. Hello? Next slide, please. Oh, this is a little old slide for some reason. Okay, but it's okay. So yeah, but the purpose of this draft is basically simple. It's try to provide a solution for the option space in Syn segment. And I think this is, well, very old issue and a well-known issue. So I don't have to explain the background carefully, very detailed. So I just skip this slide. So moving on, okay. And then there are several previous proposals for these issues. But I'm going to skip this slide as well, because people know this issue a little bit more, already know this one. So basically, our approach is combining two approaches. One is aggregated option. The other one is delayed option negotiation. And then by combining two approaches, it's try to save option space in segment. Moving on to the next slide, please. So what is aggregated option? Aggregated option is basically designed based on the fact that some options have a very simple format in segment. Simple format means just it's code point and the length. That's all. And for example, SAC permit or first option cookie or EDO or tar option, and this is an example of such kind of option. And the reason why this option has a very simple format is that they are used for just for indication of the feature. Indication of the feature means that just endpoint claim that I want to use this feature. That's it. And this is kind of one bit information. And because the TCP option format, each option need to use its code point and the length at least, and then also EXID if it's an experimental option. And then because of that, each option need to consume 2 or 4 bytes or more option space. And then, so idea here is if we can aggregate them into a single option, then we can create some option space in segment. That's the basic idea for aggregated option. Also, please go to the next slide. This is option format of aggregated option, but I skip this slide. Please move on to the next one. This is example usage of aggregated option. In this case, client send normal options such as timestamp and or window scale. And then in addition to them, it send aggregated option. And then inside aggregated option, bits for option A and B are set. And then on the server side also, in addition to the sending normal options, it send aggregated option. But in this example, only bit for option B is set. Bit for option A is not set. And in this case, basically option A is not negotiated, but option B is negotiated and will be used in this connection. So like this way, by using aggregated option, it can negotiate multiple option in a single option, so that we can save the space. That's a basic example of the aggregated option. So moving on to the next slide, please. So now I would like to talk about the delayed option negotiation. The key feature of the delayed option negotiation is it's basically extended MPTCP option exchange scheme for more generic purposes. And so it's supposed to be very simple to easy to implement, and it's supposed to be middle box friendly. And moving on, please go to the next slide. And then, so before I explain delayed option negotiation, I just would like to explain MPTCP option exchange. So left side figure indicates window scale option exchange. In this case, it's simple. Client send window scale option in segment. Server send back window scale option SYNAC. That's it. But in case of MPTCP option, it need to use 4 segments to negotiate. And then the important point is when client send the SYN packet, MP capable option is very small size. It's just a 4 bytes, so that it can save some option space in SYN segment. Instead, when client send the 3rd segment, ACK for SYNAC, it's sending a rather big byte, MP capable. It's 20 byte of MP capable option, and the 4th segment server send another big segment, another big option, 22 or 24 bytes. So that's the MPTCP option exchange scheme. And moving on to the next slide, please. And then now I would like to show the abstract view of TCP option exchange. And so basically sending option means basically two purposes. One is indication of the feature, and then the other one is additional information for the feature. Indication of the feature means that endpoint claim that I want to use feature. Additional information for the feature is, for example, in case of window scale option, window scale parameter is example of the additional information. And then usually in normal option, in the case of the feature and additional information for the feature is integrated into a single option. But in case of MPTCP, it's basically separate two information. So when client send a SYN packet, it just send the indication of the feature. I want to use MPTCP, that's it. And then instead, in the third segment, client send additional information for the feature. That's why the size of the MP capable option in third arc is very big. And then server side also send back as a confirmation for reliable option negotiation scheme. So that's the MPTCP option exchange scheme. And please move on to the next slide. And then, so basically, delayed option negotiation utilize this MPTCP option exchange scheme concept, and then utilize it for more generic purposes. So it supports 4-way exchange and a 5-way exchange. And in case the left figure indicates a 4-way exchange, in case of 4-way exchange, the option negotiation scheme is very similar to MPTCP. When client send a SYN packet, it just send the indication of the feature in SYN segment so that it can save space option space in SYN segment. In case of 5-way exchange, in addition to the SYN segment, when server send SYN ARC, it's also send the indication of the feature so that it can save the option space in SYN ARC. And so it depends on how much option space it wants to save. Server can choose 4-way exchange or 5-way exchange. That's the basic idea of delayed option negotiation. Please move on to the next slide. And this is option format of delayed negotiation, but I will skip this slide. And then this is example usage of delayed option negotiation. And basically delayed option negotiation is utilize aggregated option. So when client send a SYN packet, in addition to the normal options such as timestamp of window scale, it's use aggregated option. And then in this case, bit for option A is set. And then server side is similar, same way, send back normal option and the aggregated option. And the bit for option A is set inside aggregated option. And then when client receives SYN ARC, the option A is negotiated. So in the third segment, client send the normal format of option A to send additional information for this option A. And then also it send the 2-byte aggregated option to indicate this packet contains additional information. And then server side also do the same things. It's send the option A with normal format, and then also send a 2-byte aggregated option to indicate this packet carries additional information. And then on the fifth segment, the client send a thin aggregated option. This is an indication of the confirmation. So this is a basic usage of the delayed option negotiation. Please move on to the next slide. So this is my end slide, final slide. And so as I explained, so this approach do not option space in SYN segment. Instead, it's compress options in SYN segment, and then also move some part of the option in segment to non-SYN segment. So it's not extending the space. So you might think it's just moving problem to other place. So because if we do this, maybe non-SYN segment may get crowded, may run into option space. But in this case, if the no-option space segment is running out of space, we might be able to use EDO because EDO cannot be applied to scene segment, but EDO can be applied to non-scene segment. So if by combining EDO and this approach, we can solve the option space issue. So I think, so this is it basically. We believe this is a practical approach. So unlike previous approach, we don't change feather format, or we don't send multiple scene packets and for a single connection. We don't do that. It sounds like it's a bit tricky, but this approach is more practical, so that's easy to implement. And basically that's the basic idea. And so this work is just started. So for more detailed information, please read the draft and then please provide a feedback. Thank you so much. If you have a question, let me know. Okay, BD?
For the draft, this is pretty cool. I just have one question. When we want to use and send the options in the third segment, what options are you thinking? Because MSS, timestamp, window skills would not classify, right? Like which options? Maybe the the TARR option. Is there anything that you think would fit in the third segment?
That's very good point. Yeah, actually, MSS is tricky. Windows scale is really tricky. And then, yeah. So what I'm thinking is, more future. If people try to invent new options, then they might run into option space issue. Then, and then even if it's a cool idea, sometimes we don't have a option space. Then people do not activate the feature. That's the scenario I'm concerning. So I think the focus is more like a newly invented option rather than currently existing option.
That sounds great.
Thank you. Okay, so I will continue the discussion on the mailing list. Okay, so the next presentation is Alexander.
You can hear me clearly and loudly. So I don't have very much time left, and I'll try to make it fast. My name is Alexander Azimov. I work for Yandex. This is a follow-up to the discussion that happened a few months ago in the mailing list. And unfortunately, it wasn't that fruitful. Next slide, please. So this time I tried to do my homework and carefully read all documents that are related to flow label generation. So these are documents that you can get if you enter flow label in the search engine of the data tracker. And not all of these documents are responsible for flow label generation, but I will make a quick recap of the most important ones. Next slide, please. Thanks. These two documents discuss application for both stateful and stateful use cases. On the slide, there are a few quotes that I'd like to highlight. The first clearly states that flow is connected, but not necessarily mapped one-to-one to transfer connection. This document also specifies label as 0, but it's a special case. And more important, it's non-zero flow label should not be changed by the label box. So this is unprotected, so flow label must not be used alone in the cache function. The second part of the discuss use of flow label as a network function, and let's move to the next slide. RFC 6294 discusses use cases of flow label as a for packet classification. Using flow label, this brings additional limitations and significant technical requirements. The flow label should be strongly fixed to a selected flow. Routes support flow label based states. They should support processing of unknown flow labels and, of course, garbage collector. And mostly it mimics what we are using quality of service or MPLS labels in networks. And since the document is 10 years old already, we can say that with high confidence that there were no real deployments of a flow label that uses stateful approach. Next slide, please. So RFC 6436 finally finishes the arguments and states that flow label should not be used as end-to-end signal of any kind. It also states that flow label may be used only as part of hash function for stateless load balancing. Next slide. This RFC expands the idea of stateless load balancing, and it's the support of load balancing with a flow label to different kinds of encapsulation, for example, GRE or IP tunnels, and of course, in nowadays it's also important for SR36. Next slide, please. And this is the last, at the moment, RFC related to flow label generation. It's a bit out of the line. It discusses the use of flow label in the layer 4 load balancers, which relies on the immutability of flow label, which makes it in conflict with 6436. It also creates a new attack vector with fragmented packet flooding. And once again, speaking for myself, I'm not aware of any kind of these kinds of implementations. And if there were some, they should have already experienced working with Linux boxes. Anyway, let's move on and look at what was happening in the Linux kernel. Next slide, please. So 2014, one of RFCs, if we speak, it's related to encapsulation or tunneling, was implemented in the Linux kernel. No surprise at the moment. Next slide, please. Next year happened a very important update to this functionality. Upon negative routing event, most of you should know it is as RTO timeout. The hash that is related to the flow label is recalculated. Next slide. Next slide. Oh, okay, good. And the next year, this solution is further strengthened. Now the hash and corresponding flow label is changed after each RTO timeout, both if it's happening for thin packets and if it happens in the middle of a TCP connection. Next slide, please. Next slide. Oh, okay. It takes some time to refresh it, at least in my window. Why it is that important?
Hurry.
Yeah. Because in certain scenarios with multiple alternative paths, it gives TCP flow a fantastic problem. In case of packet loss, the session may jump from one path to another path. The more alternative paths you have, the higher is the chance that network outage will have a zero effect on your services. What do you need to make it real? You need to enable flow label enriched load balancing on egress devices. In this particular example, if we have an outage on the device S1 and we lose a sync packet, the circuit cache will be recalculated, we'll get a new flow label and a chance to reach the destination through not affected path. Next slide, please. Here is an experiment that took place on a production traffic in one of Yandex data centers. For that, we used the top of rack switch with 4 uplinks. And one uplink on one uplink, we created a sale, so they dropped all the traffic that was coming from service through this. On the left, you can see the output of our data plane monitoring that shows 25% packet loss. On the right, the disruption that happens with services. Next slide, please. Now, if we enable flow label hashing on the top of rack switch, the picture is changing dramatically. As you can see, packet loss from our data plane monitoring, which is not aware of any TCP, is still the same. It's still 25% loss, but services are not affected anymore. Of course, this also requires some fixed RTO timeout values, but anyway, it wouldn't be possible without the flow label changing at the host. Next slide. And as we discussed, RTO timeout is not only flow label. It also affects all kinds of encapsulation. In case of GRE, it affects key fields. In case of UDP encapsulation, it affects soft port. Next slide, please. And one is default behavior. So Linux kernel developers have improved Linux stack and enriched TCP that works over IPv6 with self-healing properties. Though they haven't standardized it in any kind. Today, we have multiple paths, not only in the data center environment. Most of the users may have improved quality of service that is growing from these changes. But if it was that great, I would this slide, and you haven't been suffering from my Russian accent. Next slide, please. We're in a hurry. The side effect occurs if RTO happens on the client side during upload, for example. The flow label change may redirect TCP session to another node, for example, to another TCP proxy. In this case, TCP session will end up with a timeout. We have faced this issue with our users and had to switch off flow label hashing at routers, though it helped only in subsets of cases. In general, if you see more timeouts during uploads in IPv6 than in IPv4, now you should know why. On the other hand, full rollback sounds like a valid option because the property of self-healing is highly desirable, and it seems that it can be easily fixed. Next slide, please. In TCP, we have two sides, it's obvious. The client who sends SYN packet and the server who responds with a SYN ACK. The problem that I have described may occur only if the client changes the flow label while connected to a stateful anycast service. So we can keep current defaults for the server unchanged and recalculate the hash on each RTO timeout. In opposite, the behavior for clients should not need hash recalculation, although there should be a knob to enable it in a controlled environment. Next slide, and it will be the last one. There are multiple RFCs related to flow label generation, though some of them look obsolete. There are non-standard behavior in the Linux kernel that may, and maybe other operational systems, I'm not aware of it, that improves connection stability in case of packet loss that affects a subset of available paths. Unfortunately, it's also introduced a mistake that may result in TCP connection timeouts during uploads. It can be fixed, and from what I learned in the mailing list, it will be fixed, which is good. But I believe it's also important to update related standards and reflect what is happening in real-world deployments. Otherwise, there will be a growing gap between what is written in 10 years old documents and real implementation. Thank you. So if we can take a couple of questions, it will be great.
questions. Sorry. Can you hear me?
Yes, I can
Yeah.
hear you.
Okay. One question I have is it depends on SKB hash, right? So not all implementation use SKB hash to generate flow label, and then we don't want to standardize very implementation specific algorithm. My understanding.
We are not define how to you are calculating the hash. But it can be specified that the hash is calculated for the socket without specification the algorithm itself, and how it is related to flow label. It's not only flow label. It's how it is related to behavior.
Okay. Martin? Oh, okay. Gori?
I think it's interesting to see people practically using the flow label. And if you go to other working groups in the IETF, you'll see people debating whether this is used, how this is used, and whether it changes. So this is part of a much bigger discussion. So it's really good to see this presentation here.
Thank you very much. I can say that at least 3 hyperscale clouds at the moment are using flow label this way.
Bob?
Hi there. To save time, I've put you some references on the chat for a document called The Social Cost of Cheap Pseudonyms. And the problem with the flow label, if you start using it to represent other fields that say what the flow is, it's just so easy to shard flows and take advantage of systems that depend on the flow labels, which are already cheap pseudonyms. So I encourage you to look at those references and think about them. Thanks.
So are you speaking about stateful approaches of using flow label?
Well, I'll give an example on the list. For instance, an FQ scheduler gives advantage to short flows. So if it assumes that a flow label maps to each flow, then you can just shard the flow labels and get more advantage out of the scheduler.
Do you know any real deployments of such a feature?
What, of an FQ scheduler? Yeah, they're
Please take it offline.
Yep. That's why I said look at the list, look at the chat.
Yeah.
Okay, I'll check it. I'll double check it. Thank you for the comment.
Okay, very quick.
Yeah, as an individual. So the question for me is if you should have, if this not one-to-one mapping means you can have multiple flows, multiple flow IDs for a single TCP connection. Because this is just about changing the flow ID in the middle of a TCP connection.
Yes, it's not about only changing in the middle of TCP connection, but only the state of establishing TCP connection. And of course, the reason why it is connected to RTO timeout was changing this point in time mostly guarantees that there will be out of order with obvious consequences.
Yeah, I just want to make clear that we can formulate this without looking into the way Linux has implemented this.
Yeah,
so
yeah,
this
yeah.
is the
Sure.
Just
yeah,
a clarification.
Yeah, thank you. Thank you for the comment. I got it.
Okay, Jonathan, very quick.
Yeah, I just feel a need to answer what Bob said. Since I'm very interested in FQ-based AQMs. So one obvious way to guard against this would be for the flow mechanism to look at the port numbers as well as the flow label and to perform fairness between flow labels within the same 5-tuple. Just one example of how to deal with that situation.
Yeah, but then I don't think the purpose of this work is to, I think the purpose of the work is not to have to go to layer 4 in the network.
Okay, yeah, thanks for lots of interesting discussion. Thank you so much. I think time is up. And thank for many comments, productive discussion. So this is the end of the session. I hope we can see you in San Francisco in summer.
Just a last comment on top of this discussion, if you don't mind.
Okay. Okay.
So from the feedback of this working group and also from the feedback that I learned the V6 operationals working group, I believe that there is the feedback is mostly positive, and it might be important to standardize it. Though I'm not sure that I want to author this document, but I will try to contact those kernel hackers that did in Linux and ask them if they want to proceed this work on IETF.
Okay. Anyway, please provide internet draft, and then we can think about how to proceed.
Yeah. Sure.
Okay, any more last comment? Okay, thank you so much. So see you next IETF.
See you.
I'm sleepy.